Welcome to the Explainer. You know, it's kind of wild when you think about it. You type some words into a text file, and a computer somehow knows exactly what to do. How does that happen? Well, today we're pulling back the curtain on a super critical piece of that magic, the parser.
So let's just start with that big question right there. How does a machine make any sense of our human-readable code? It's not magic, of course. It's a very clever, step-by-step process. And right in the middle of it all is a hero called the parser.
Okay, so here's our game plan. First, we're going to define what a parser actually is. Then we'll dive into the two major ways they work. It's a top-down versus bottom-up showdown. And finally, we'll take a look at the whole parser family tree to see how these ideas branch out.
All right, first things first. What is this thing? You can think of a parser, or a syntax analyzer if you want to be fancy, as the bridge between you and the computer. It's basically the grammar police for your code. It checks to make sure everything you wrote actually follows the rules of the programming language.
Here's a great way to think about it. Imagine you wrote a sentence. A parser first checks if that sentence is grammatically correct. But it doesn't just stop there and say, yep, looks good. It actually diagrams the sentence, figuring out the subject, the verb, the objects, all the structure. That diagram, for code, is what we call a parse tree.
And this slide is so important because it shows you exactly where the parser jumps in. See, before the parser, another process called lexical analysis breaks your code into little pieces called tokens. But at that point, it's just a flat list of words. Int, ID, equals, there's no meaning yet. That's when our hero, the parser, steps in, takes that jumbled list and organizes it into a structured tree that the computer can finally understand. Now, here's the thing. Not all parsers are created equal. They pretty much all fall into one of two main camps, two competing strategies for how to build that tree. And it really just comes down to where they decide to start.
And this lays out the difference perfectly. A top-down parser is like a detective who has a theory, the main goal, and then looks for clues in your code to prove it. A bottom-up parser is the opposite. It's a detective that starts with all the clues, your code, and tries to piece them together to figure out the theory. So for top-down, the big question is, which rule should I use next? For bottom-up, is it time to piece some clues together yet? So let's dive into that first strategy. We're going to get inside the head of a top-down parser and see exactly how it tries to build a piece of code based on a set of grammar rules.
Okay, let's say our parser's mission is to create this exact string, A, B, C, D, E. Being a top-down parser, it starts, you guessed it, at the very top. It begins with the single biggest rule in the whole grammar, which we usually just call the start symbol, or S. The parser cracks open its rulebook and sees a rule that says S can become A, B, E. It says, perfect. By applying this one rule, it's already managed to match the first A and the last E of our goal. Awesome. Now it just needs to deal with those two capital letters in the middle, A and B.
Now this is where the leftmost derivation part comes in. It always works on the leftmost symbol that can be expanded. In this case, that's the first capital A. It looks for a rule for A and finds one that turns it into A, B, C. And just like that, our string gets even closer to the target.
And it just keeps doing that. What's the next leftmost thing to expand? It's that A, which it replaces with a lowercase a. And the last piece of the puzzle? That B becomes a D. And boom, it has perfectly built the target string from the top all the way down. The syntax is valid.
Okay, now let's completely flip the script. Let's look at the other way of doing things, starting with the code itself and working our way all the way back up to that main rule. So, this parser starts with the evidence, the finished string. Its whole goal is to find patterns that it can reduce, that's the key word here, by using the grammar rules in reverse. The hope is to keep reducing until all that's left is that single start symbol, S. So it scans the string and spots something. It sees that lonely lowercase a and knows from its rulebook that there's a rule like A becomes A. So it does the rule in reverse. It performs a reduction, swapping out the A for the capital A. It scans again, and this time it sees an even bigger pattern. The sequence A, B, C matches another rule. So it reduces that entire chunk back down to a single A. See how the string is getting shorter and simpler? We're climbing up the tree. And it just keeps going. The D gets reduced to a B. And then for the grand finale, it looks at what's left.
AABE, and recognizes that this matches the big starting rule. It reduces the entire thing down to S. Mission accomplished. The string is valid.
So as you can see, these two very different ways of thinking, top-down and bottom-up, they're like the two ancient ancestors of a whole huge family of different parser types that we use today. The family tree splits right down the middle into our two main branches. Now, inside the top-down family, a big difference is something called backtracking. That's basically the ability to say, oops, I took a wrong turn, let me back up and try a different rule. On the other side, bottom-up parsers are often called shift-reduce parsers, which is just the technical name for that process we just saw, shifting along the string and reducing chunks of it. And as you zoom in, you see even more specific types. The most common top-down parsers are called predictive because they're designed to be smart enough to look ahead a little bit so they don't have to backtrack. These are known as LL parsers. And on the bottom-up side, the real powerhouse group is the LR parsers, which are incredibly good at that whole shift-reduce dance. But even within that really powerful LR family, there are levels. As you can see here, a CLR1 parser is the undisputed champion. It can understand the most complicated and tricky grammars out there. But all that power comes at a cost. They can be really complex. That's why a lot of real-world compilers use something like LALR1, which hits that sweet spot of being really powerful, but also efficient.
So here's the bottom line. It doesn't matter if you're building from the top down or the bottom up, the parser is the absolute key. It's the thing that takes a simple flat line of text and transforms it into a rich, structured tree that the computer can actually understand and act on. And that leaves us with one last thing to think about. Every single programming language you love, whether it's Python, Java, JavaScript, or C++, relies on one of these strategies. Its creators had to make a choice, top-down or bottom-up. So go look it up. It's pretty interesting to find out which path your favorite language decided to take.